Welcome to Algebra 2, Unit 7, Section 4, Fundamental Theorem of Algebra. After today's lesson, I can use the fundamental theorem of algebra to determine the local number of roots, the total number of roots a polynomial has. Okay, so what did we notice about the degree of a polynomial compared to the zeros or roots, right? Well, we noticed that the degree of the polynomial is equal to number of zeros or roots. So the fundamental theorem of algebra states every polynomial equation with a degree greater than 0 has at least one root in the set of complex numbers. Now the corollary to this is that polynomial equation of degree n has exactly n roots in the set of complex numbers included repeated roots. Okay, so now complex numbers are in the form of a plus bi. Okay, we've been used to dealing with the value of b is 0, that there's no values with an I in there. Those zeros, though, do occur, and we're going to take a look at some problems here. But basically what we end up with are, for the most part, we're going to stay away from that stuff. So, using the fundamental theorem of algebra, determine the degree of each polynomial and what the roots are. So x squared plus 3x minus 4 is factored as into x plus 4, x minus 1. So this is a second degree polynomial, and there are two roots. Okay. Oh, and the roots, let's go back to that. So what are the roots exactly? Okay, so our roots in this case would be negative 4 and positive 1. This is a fifth degree polynomial, x to the fifth minus 4x to the fourth plus x cubed plus 10x squared minus 4x minus 8. But you'll see here we have some multiplicity of this one has 2 and this one has 3. So our roots, though, are just negative 1 and 2. But their multiplicities, negative 1 has a multiplicity of 2, and 2 has a multiplicity of 3. Okay, our last one here is a third degree polynomial. Our roots, in this case, are 3, and we would have x squared. All right, so we have to do a little work here. So x squared plus 4. Well, we'd have to equal 0. So then we'd have x squared equals negative 4. You take the square root of each side, and that would be x is equal to the square root of negative 4, which is equal to the square root of 4 times the square root of negative 1. So that's equal to 2i. So 2i is a root, but it doesn't show up on our graph. So because of that, all right, that is a complex root, right? This is a complex number, all right? Now, let's continue on. Given the following information, determine the degree, okay? So 1 has a multiplicity of 2, negative 2 with a multiplicity of 1. So this degree would be it'd be a third degree polynomial. So we'd have our zeros are x minus 1 squared and x plus 2. From here, we would take this polynomial, we can square this, square the first term, multiply the product together. Negative 1 times x is negative x, and then double it, negative 2x plus 1. So then now we're going to multiply that by x plus 2. So, alright, so from here we end up with x times, I'm going to go this way with this. I'm going to multiply this like so, and negative 2 or 2 by this way, and then we'll combine our like terms. So x times x squared is x cubed, x times negative 2x is negative 2x squared plus x. 2 times x squared is 2x squared plus 2x. Let's fix that. Plus 2x squared minus 4x plus 2. Alright, so we end up with x cubed minus 2x squared plus 2x squared is 0. X minus 4x is minus 3x and plus 2. So factored, we would say this is x minus 1 squared, x plus 2, and multiplied together we'd have x cubed minus 3x plus 2. Okay, so let's take a look at this one. Negative 3 with a multiplicity of 1, so this would be x plus 3. 0 with a multiplicity of 2, well that's just x. Anytime you have 0, or for the 0, it's just x. So we're going to put this up front. We'll put x squared plus this. And then x minus 4 with a multiplicity of 2. Alright, so let's go ahead and go through this process. X minus 4, we'll square that first. So we're going to end up with, we'll say x squared times x plus 3. And we're going to figure that out. So x squared, negative 4 times x is negative 4x, double it, negative 8x, and then square this last one, plus 16. Now I'm going to distribute, again, we're going to distribute this one over here, and we'll do this over here then. Okay. So I'm going to have x squared times x squared is x cubed. X times negative 8x is negative 8x squared plus 16x. And then plus 3x squared minus 24x plus 48. 3 times 6 is 48. So we're going to end up with this as being x squared, x cubed, negative 8x squared plus 3x squared is minus 5x squared. 16x minus 24x is minus 8x, and then we are at plus 48. Now we're going to distribute x squared, so we'll put this down here, x to the 5th minus 5x to the 4th, right? We add our exponents, minus 8x cubed plus 48x squared. And then factored, we would just keep this from the first line, x cubed, x plus 3, x minus 4 squared. Okay? So there's a bit of work. So that concludes our discussion of 7.4, the fundamental theorems of algebra. Have a great day. Peace. Alright, welcome to Algebra 2 Unit 7, Section 5, Graphing Higher Order Polynomials. So after this lesson, you can determine the key features of a polynomial equation, and you can apply the key features to sketch the graph of a given polynomial equation. So steps to graphing a polynomial equation. First, we want to determine end behavior using leading coefficients and degrees. Second, we want to find the real zeros by determining multiplicity. Third, find the y-intercept. 4, plot the zeros and y-intercepts. And number 5, sketch the graph. Alright, so we're given this function x cubed minus 2x squared minus 5x plus 6. So our lead coefficient on this is 1, positive 1. And this is a third degree polynomial. So this means that as we approach infinity, positive infinity, that we'll be approaching positive infinity on the right. As we go left and we approach negative infinity, we will then be going down, so this will be negative infinity. So next we want to find the zeros. So we have 3 zeros because this is a third degree polynomial. Our p-value, again, is the value of the constant. It's 6, right? So we're going to take and factor 6, right? So 6 is the value for p. The factors of 6 are 1, 2, 3, and 6. Q is equal to 1. So all our roots are 1, 2, 3, and 6. So what we can do here is we're just going to do some polynomial division, and we will start with 1. So we've got 1, negative 2, negative 5, and 6. We're going to do synthetic division here. So let's go through this process, and 1 comes down. 1 times 1 is 1. Negative 2 plus 1 is negative 1. 1 times negative 1 is negative 1. 5 and negative 1 is negative 6. 1 times negative 6 is negative 6. 6 plus negative 6 is 0. So we've figured out what our first root is, right? So our first one is the number 1. Now, I'm looking at this next one. I've got negative 6 here. So I'm going to take a look at the number 2, but I'm going to make it negative, seeing that we have a negative value. So negative 2, and we are going to say, you know what, let's move this up here. Hold on. Let's do this right here. Why, instead of reinventing the wheel, why don't we just go like this and like this, and like this, and we'll put negative 2 here. So 1 comes down. 1 and negative 2 times 1 is negative 2. Negative 1 plus negative 2 is negative 3. Negative 2 times negative 3 is positive 6. So this becomes 0. So our last factor is x minus 3, right? This is a 0 right here, which makes the last 0 equal to 3. So we have 1, negative 2, and 3. The y-intercept is always the constant, which, if we go back up here, we can see is 6. So we have a y-intercept at 0, 6. So now, step 4, plot the zeros and the y-intercept. So let's go ahead and do that. So our zeros again are 1, negative 2, 3. Our y-intercept is 6. Okay, so our end behavior tells us that this function is going to be down here doing this, and this part of the function is going to be up here doing this. Alright, so I'm thinking the peak of this is going to be somewhere around here. So we're just going to come up like so and come back down like this. And then we cross over and under. Alright, because each one of these has a multiplicity of 1. They have to cross the x-axis. So, as a means of checking our work and seeing how we did with sketching our graph, we're going to plug this in to our graphing calculator. So we're going to clear some stuff out here, and we're going to plug in x cubed minus 2x squared minus 5x plus 6. And we're going to take a look at our window, and let's make it look just like the one we have, -10 and 10. And we're going to go over here, and our y minimum is -10, and our y max will be 10, and our scale will be 1. So we can go ahead and graph this. And as we can see here, we didn't do too bad. Pretty close, right? Not as pretty, but we got the sketch down. It was just a sketch. Let's work on another one. So now, as we go through and analyze, lead coefficient -1. The degree is 6, so this is an even degree function, which means we're going to be finishing in the same direction for both of them. So what this function says is, okay, as we approach positive infinity, since this is negative, it's going to be negative infinity. Both end behaviors are going the same direction. So as negative infinity here, this is also negative infinity. We should have 6 zeros, right? Because it's a 6-degree polynomial. Since this is already factored for us, we don't have to bother finding p and q, so we don't need to bother with this. Our roots, we can just go directly possible root -1, +2, +4. And our constant here is 16. Right? So we'll refill this here. And this is at 0, 16. Okay, so we're going to come back up here, and because we don't have 16 places on this graph, we only go up to +10 on the y-axis, we're going to scale it by 2. So I'm going to go right up here, 8 up, and that's going to be 0, 16 right there. But we're going to keep our x scale the same. So we have -1, 2, and 4. Now we know that this graph is going down, so we're going to be doing this right here. Okay. Now one of the things we look at is the multiplicity. So -1, right? So -1 has a multiplicity of 3, and +2 has a multiplicity of 2. So if you recall in our conversations about this earlier, so this is going to be a slash, right? We call this a slash, so let's get rid of this here. We're going to be coming across on an angle like such. And then we'll come down here like so. Okay, and then we're going to work up through this point here, right? We're going to be working up through that point on the y-intercept. And then we're going to come back down, and then we're going to bounce off of here because it's a multiplicity of 2. So we're going to touch and go, and then we're going to come back down, right? And this is just a bad looking graph of like a rabbit. Looks like a bad rabbit drawing. So let's see what we get when we graph this function. So we have negative x to the 6th plus 5x to the 5th plus x to the 4th minus 21 x cubed minus 4x squared, oops, not times, minus 4x squared plus 28x plus 16. And we're going to have to make some adjustments, I'm pretty sure, here to our window. So let's do that. I'm going to stay with negative 10 and 10, but our y minimum and our y max I'm going to change. And having done this problem a few times, I'm going to show you that we want to go to 100 here. And our scale, let's make 10. So as we graph this, you're going to see this touches and then goes way up and comes back down. So I realize that this graph looks nothing at all like what I drew, right? So that's the actual. But we do have this general idea of this part right here. Okay, we have this piece right here where we work the slash. Okay, we did hit our peak here. We did touch and go here. Okay. And then we came through 5 right down here. Or, yeah, 5. Okay. Let's do another one. Okay, this one tries to be a little tricky because our lead coefficient, if we look inside the parentheses, we say it's 1. But because we have to distribute 0.4, our lead coefficient would be 0.04. Our degree is 3. So again, as we approach positive infinity, we'll be approaching positive infinity. And as we approach negative infinity, we'll be approaching negative infinity for our end behavior. Our zeros we should have is 3. So our zeros here are 5 with a multiplicity of 2 and negative 3 with a multiplicity of 1. Our y-intercept is not 75, right? We have to do 0.04 times 75. So we take out the calculator here and we clear this here. And we say 0.04 times 75. And that comes out as 3. So come down here. And our y-intercept is 0.3. So we'll go to 5, and we put a dot here, and negative 3, and then we're going to have this point of 3. Now, if we go back to what we learned last semester, when we have a coefficient here of 0.04, it's less than 1, it flattens this graph down and it smooths it. So our graph is going to be looking somewhat like this. We're going to have a nice curve here and a nice come down here and touch and go and then up. And then this one is going to continue like that. Alright, so that's my rendition using this knowledge base. But we'll take our calculator and we're going to go ahead and plug it in. So clearing this, I have 0.04 parentheses x cubed minus 7x squared minus 5x plus 75. And I hit enter. And I think we can take our scales back to where we had them. So we'll go to y maximum of 10 and the scale of 1. Right? So we can go ahead and hit that. Let's see what we got. And we touch and go like we said. I think my angle of approach is off a little bit, comparatively speaking, right? Right, this should be coming down here more versus what we have with our graph on the right. All right, our last graph. Same process, but instead of a decimal now we have a fraction. So our lead coefficient here is going to be 1/16. We're going to have a smoothed down graph. The degree is 6. Since this is a positive even graph, as we go to positive infinity, we'll be going up. That's positive infinity. And as we go to negative infinity, we'll still be going to positive infinity, which is up. How many zeros should we have? We should have 6 zeros. What are those zeros? Well, we have 3 with a multiplicity of 2. We have -1 with a multiplicity of 2 as well. And we have -4 with a multiplicity of 2. So this graph and the y-intercept, well, we have to multiply 1/16 times 144. Or we can just divide 144 by 16. So that's what we'll do. We'll make life simple here. 144 divided by 16. And I get 9. So my y-intercept is at 0, 9. So let's go ahead and start graphing. So I don't want that color. I like my blue color for this. So here's our y-intercept there. So we have a x-intercept at 3, another one at -1, and another one at -4. And since we are both sides are going as such. Alright, so I'm going to guess we're going to maybe, let's see if we are somewhere in this area, but I'm just going to come up and down like so, and up here again, and come back down. And our graph should look something like that. Okay, so let's use our graphing calculator and see what we come up with. So y is equal to, and we're going to clear this out again. We're going to put the fraction in, so it's alpha, hit y equals, and then the number 1. We can put a fraction in. So 1/16. And then I'm going to put in x to the 6th plus 4x to the 5th minus 18x to the 4th minus 68x cubed plus 73x squared plus 264x, not 364, 264, and then plus 144, and close my parentheses and hit enter. So if we leave our graph alone, what do we have here? Okay, well, let's do this. Let's adjust our window. And let's do our y minimum to -10. And let's go, I believe, if I remember correctly, we might want to go up to 80. And we'll use our scale being 10. Let's see what we got here. Oh, wow. So we don't need to go. Let's go up to 4. Let's make that 40. There's 40. And we'll change this scale to 5. Let's see what we get here. Something a little bit more. There we go. All right, that's not bad. So there is our final graph. Okay, granted, we had to make some adjustments with the scaling, right? But overall, we kind of get the idea about these humps like this. So that is graphing higher ordered polynomials. Have a great day. Peace.